Hello, my dear friends. Now in this session, we will take up a chapter called mensuration. It's a small and simple topic. There would be direct questions asked on the topics related to mensuration. Mainly the questions are related to lengths, areas, and volumes, right? So we'll take them one by one. Let's take up the first topic that we have in this session is things related to triangles, right? So what we will do is we will take up first all the general formulae related to triangles. All right, let's see. What is a triangle? Triangle is three-sided polygon. So we have drawn a triangle here. Let's give it a name. It has three vertices, A, B, and C. Usually we take the vertices as capital letters. The sides opposite to the vertices, like say for example, capital A opposite to that side BC, we will call it small a. Usually that is the convention. Now opposite to B, we can take it small b, and opposite to C vertex, we can take the side AB as small c. Now there are different terms attached to it. So first, general rules or general formulae related to triangles. The first one would be a term called perimeter. Now what is the perimeter? Perimeter is a simple sum of sides. So here the perimeter is equal to A plus B plus C. Small a, small b, small c are the presentations for the sides. Alright. Then the second term that we have, which will be used very frequently, is semi-perimeter. Semi-perimeter usually presented as small s, and it is equal to half of perimeter, and effectively it becomes s is equal to a plus b plus c divided by 2, right? Or you can also say that a plus b plus c is equal to 2s. Alright. Now the next thing that we have is related to triangles is the general formula of area of triangle. Alright. Now, area of triangle can be calculated in many ways. So what we'll do is we'll try to learn or try to recall all of them. The first one is the general formula, and it is called Heron's formula. According to Heron's formula, the area is equal to, if I have the sides as A, B, and C and the semi-perimeter as S, then the area will be calculated as square root of S into S minus A into S minus B into S minus C. So this is one primary formula for area of triangle. Alright. So if all the sides are known, right, this is one standard method of finding the area of a triangle. Alright. So from ABC given, you can calculate S, because S is equal to A plus B plus C by 2, and then you can calculate the area of triangle. Alright. The second general formula for area of triangle is, I'll directly give you the formula. It is equal to half into base into height. Now to understand this, what I'll do is I'll just draw a triangle and I'll just try to show you what do we mean by saying a base and a height. Let's say if this is the triangle, and if I take, let's say, this side A as a base, then whatever the length of perpendicular is from A to this side, this will be called the height corresponding to the side A. So please try and understand that if you take a different side, the height would be different. So for example, in this case, for side A, height is h. Alright. So if I take this different, let's say if this is capital B, this side is B, for B, height would be different. This length would be the height, right? So just be very clear, right? So it is half into the base into the height. The height should be on that particular base, okay? Then there are special formulae for different types. Let's say I will give it a name as special formula. The first one would be for right angle triangle. I hope you remember that in a right angle triangle, two sides are perpendicular. So for a right angle triangle, area is given as straight away equal to half into the product of perpendicular sides. Half into the product of perpendicular sides. Okay. So again, now what I'll do is I'll draw a right angle triangle. Let's say if this angle is 90 degrees, this is a right angle triangle. Suppose this side is A, this side is B, and the hypotenuse is C. In that case, area of this triangle is straight away equal to half into AB, A into B, right? Because A and B are perpendicular sides in this, alright? The second special formula is for an equilateral triangle. For equilateral triangle, area is equal to root 3 by 4 into the side square. Right? So if you draw an equilateral triangle, and if I say the sides are all A, then the area will be equal to root 3 by 4 A square. Right? So there are three different ways in which you can calculate the area of triangle. One is, as you can see, that is Heron's formula. The second one is the general formula, half base into height in that one side, and the perpendicular height should be given. And the third one is the set of special formulae, which is based on different types of triangles. The first one, right angle triangle, that is half into product of perpendicular sides. And for equilateral triangle, it is root 3 by 4 into side square. All right. So these are the things which are applicable to all triangles. Like one is perimeter, one is semi-perimeter, and the third one is area. These are the things which are related to all the triangles. Now what we will do, we will take up specific types of triangles and we will look at if they have some specific property related to the lengths of sides or anything. All right.